Hi everyone, we're going to take our class notes on 11-6, day 2. We will be solving some exponential equations. We solved exponential in 11-2, but when we solved exponential in 11-2, a lot of our problems we were able to write, I think all of them, we were able to write with the same base. And if we were able to write both the left and the right side with the same base, we were able to use that power rule, which said same base, go ahead and set the exponents equal. Reminder on our first slide that the common log has base 10 and that the natural log has base e, which is approximately 2.71. In 11.5, they talk more about natural logs. Natural logs are used and it says in the book that it's the most important log used in applications. So all your application problems, you'll typically see an ln instead of log for log. So common log base 10, natural log base e, but e is a number. Even though we're writing a letter, it is a number. And so let's go ahead and check out how we're going to solve these today. These exponential equations that we deal with today, and you can see that first example on the screen, you can't write them with the same base. If you look at your base sheet and you look at base 4, you can't rewrite 10 in base 4. When you check base 3, you don't even see a 4 or 10, and when you check base 2, you see a 4, but you don't see a 10. So I can rewrite 4 with base 2, but I can't write 10. So there's no way of writing these with the same base, which is what we did in 11-2, and then we just took the exponents and set them equal. So we have to learn a different way. And so again, don't treat these as steps, just think of like the verifying piece, different approaches to solving exponential equations. The first one says to take the log to the same base on both sides. So we're going to be doing that a lot today. Typically, my go-to is to try to write them with the same base. I don't ever really want to bring logs in if I don't have to. Most of our exponential equations can be solved without logs. But when you can't write them with the same base and you don't know how to figure out x, you can use logarithms to solve these by taking the log, and you get to pick the base. So you have to be aware of that piece and pretty confident with what you're doing. You can pick any base that you want, and you can take the log to that base on both sides. And then you can use, again, not necessarily step 2, the other thing that we can use is the power rule, which is basically saying if you write them as the same base, you can set the exponents equal. We can also use some of the special properties here when we take the log of both sides, and you'll see that in our first example. But our ultimate goal is to solve. So let's go ahead and get started. So we've already talked about the fact that we can't write these with the same base, which means here's a case where I have to use my log. And I see a base 10 here, and I'm also focusing on the fact that I want to get x out of this location. I don't want it as the exponent. To solve, it needs to be not in the exponent location. Therefore, you could take log base 4 of both sides, but for me, I think it's easier to just take the log base 10 of both sides. So completely up to you. If you do log base 4, then you're going to use your power rule and expand. So this is where expanding would come into play, and then you'd have to do some dividing. Log base 4 of 4 would just become a 1, right? But if I do log base 10 of both sides, so I'm using number 1, take the log to the same base of both sides. I'm going to do log base 10 on both sides. Here I have a value of 4, here I have a value of 10 to the x. And so this is what that special property is saying. Remember, if your base and your values base are the same, this entire log becomes this piece. And that happens, think about expanding. You would bring the x here, and then when these are the same, right, that whole log becomes a 1. So you just have x times 1, which is 1x. Or you can use this piece and say, okay, if it looks this way, then this entire thing becomes x. So what do I have of x equals log base 10 of 4, but we're not going to leave it in exact form. I want to know what that value is. So here's your opportunity to learn where to find logs on your calculator. And I hope you have a TI-84 plus so that you can actually do and have this shortcut. So when you hit math, and I'm just going to arrow up, you can arrow down, but I'm going to arrow up, and I see this option that says log base. So when I click enter on that, I can put my 10 there, and I can put my 4 here. And you use this mainly when it's not base 10, because actually this button on your calculator is base 10. But when you have something that doesn't have base 10, you need to be able to use math and that log base to change that. If you use this button every single time, you're base 10. And a lot of equations that you're going to solve on homework are not base 10, which means you're going to have to go to math and use this. So when I hit enter, I get 0.602, and it obviously goes on. I'm going to round to the hundredths again. So I could also just use my log button, but I can only use this one because my problem, and I chose to take the log base of 10 to both sides, and I'll get that same decimal. But if I, for example, if this was like log base 5 of 4, I would not be able to use this button. I have to use the math piece. So our x value is 0.60. X equals 0.60. Second example, well, we know E, which is the base, is 2.71. There's no way to rewrite 192 with a base of 2.71. So I need to take a log to both sides. For me, as soon as I see an E, I know that I want to take the natural log of both sides because natural log has base E. So I'm going to take the natural log. This is me just taking a log to both sides. I keep the value E to the 0.02x, and I keep the value of 192 over here. Now, what does this mean, and why am I doing this? Well, because on this side, this natural log, this entire thing, if these are the same, remember, if these match, that special property says that you end up with whatever your exponent is. Again, if that's not clear, expand. Put your power out front. Expand using power rule. You should know that this piece would then be a 1, and so you get 1 times this value. Or this entire thing is the exponent. So 0.02x equals the natural log of 192. Now I don't have to put that base E there. And then I divide by 0.02 to get my x alone. Now there is a natural log button on our calculator. So I'm going to hit alpha y equals, get my fraction. And the top, I'm going to hit ln of 192. Close my parentheses. In the bottom, I'm going to put the 0.02. And I can see that I get an answer of 262.87. 262.87 for my solution. So here's just 2 examples of taking the log to both sides. That's typically what you'll be doing on this homework assignment. Remember, you get to choose your base. If you see a base E, then you definitely want to use natural log because you know that that has base E. Your ultimate goal is to get the side with the variable, the base, and the values base to be the same, because then you can just take the power and set it equal. When we're solving for x, if it's in the exponential location, you don't want it there. To solve for x, we want it to become linear, which is what I did here and what I did here as well. All right, have a great day, everyone.